Welcome to my PHP tutorial for beginners. In this video, we'll start by learning the core skills of PHP, like variables, arrays, loops, and functions. Once we've covered the basics, we'll use what we've learned to start building a fun text adventure game. All the project files and assets are included in the description, so you can follow along or experiment as we go. And don't forget to check out part 2, where we'll expand the game with a MySQL database. Okay, let's learn PHP. Let's start with the environment. I recommend using XAMPP for your server, which you can set up on your own machine. You could also use WAMP or any PHP enabled web server. I've left the links in the description. For your editor, I recommend using Visual Studio Code, but Sublime Text or Notepad++ are absolutely fine. If you want to code along, we need to download the files and open them in VS Code. Alright, first let's head over to GitHub. You can find the URL in the description below. Once there, go to the code button and select Download Zip. Save the file to your web directory. Typically this will be the htdocs folder if you're using XAMPP, or whichever directory your web server uses. Now open your file explorer and navigate to your web directory where you saved the zip file. Extract all the contents of the zip file. Make sure to remove any extra folder layers. We just want it installing in the main web directory, and that's your project's directory all set up. We can view it in a browser by copying the name of your project folder and pasting it after localhost in the address bar. Hit enter and there we go. You should see the tutorial all ready to go. Now to access and edit the files, let's open Visual Studio Code. In VS Code, go to File, Open Folder, navigate to your htdocs or web directory and select the project folder. Once the folder is open, you'll see the project files listed, and we'll start with file number 1, variables. Variables and syntax. To include PHP in your file, you first need to ensure that the file name ends with .php. That tells the server that it's a PHP file. When writing PHP code, it must be placed between special tags. The opening tag starts with a less than symbol followed by a question mark and the word PHP. It tells the server, hey, I'm about to write some PHP code. The closing tag ends with a question mark followed by a greater than symbol. This tells the server that it's the end of the PHP code and to switch back to plain HTML or just stop processing PHP. Everything in between is treated as PHP code. To display text, we use the echo statement inside the PHP tags. For a string of text, we place it in between a pair of quotation marks like this. This will output PHP goes here to the screen. For plain HTML, you simply write the HTML outside the PHP tags. When you view this in the browser, the result will display both lines of text. PHP goes here, generated by PHP. HTML goes here, written in plain HTML. The output looks the same, but the PHP code is processed on the server, while the HTML code remains static, and that's one way we can mix PHP and HTML. On each of the tutorial pages, you'll see the same 2 lines of code. I've used these to create a template to make everything more readable. Don't worry, these are advanced concepts, and we'll learn them later. But in brief, the first one gets the page name by using part of the file name, and the second includes code from another file to include things like HTML and CSS to create the grey box and include the menu at the bottom. Right, let's get back to the tutorial. You'll notice this line starts with //. This is called a comment. Comments are like notes for ourselves or other programmers. When we put this in front of a line, PHP ignores it, and these can be used on a separate line or after a command. Okay, variables. In these 4 lines of code, we're using variables to set up some information about our player, like their name, health, and skill points. Each of these lines is a variable. Think of a variable as a box where we store a value. Player name stores the player name. Here we've set it to Explorer. We call this type of variable a string, and it contains a string of characters which could be a mixture of letters, numbers, or symbols. Health is storing how much health the player has, which is 90. We would call this type of variable an integer. It's a type of variable that could be used in math to calculate a value. Skill points is a decimal value, and we've set it to 5.5. As this variable has a decimal point, it becomes what's known as a float, and can be also used in calculations. Alive is a true or false value, also called a boolean. In our example, true means that the player is alive. We would use this type of variable for decision making later on. Let's have a look at 3 different ways we can include the variables in a string. We'll cover each one and why we would use each method. As we work towards building an adventure game, you might want to display a welcome message to the player or a stats bar. You'll need to include all the variables, the name, the health, and the skill points in this. First, let's take a look at this line. Let's look at curly braces. These are like a special spotlight for your variable. So why would you use these? Well, curly braces help PHP understand where the variable starts and ends, and this is especially important when the variable is next to other characters or words. It avoids confusion because without curly braces, PHP might get confused about whether something is part of the variable or just plain text. The next method is concatenation with periods. Here, we're using periods to glue pieces of the string together. Think of it a bit like snapping Lego bricks together to build your message. So why would we use concatenation? Well, the first reason is flexibility. You can bind the variables with plain text and HTML without having to worry about PHP misinterpreting anything. And the second is preference. Some developers find it easier to read when variables and strings are separated like this, allowing you to build your string step by step, one piece at a time. Our third method is placing variables directly, and this is the most straightforward method. In this case, the variables are placed directly in the string. This is like baking ingredients straight into a cake. Everything's mixed together. And why would you use this method? Well, it's quick, clean, and easy for short, simple strings. And also readability. Beginners often find this the easiest to understand since the variables appear exactly where you want them in the message. However, you do need to be careful with more complex strings or where variables are next to special characters, and that's where the curly braces might be a better idea. Let's look at managing strings. Okay, building on what we've just learned, we'll go into more detail about working with strings and variables. As per our last chapter, we start by creating a variable called player name and join it to another descriptive sentence. This might look like a lot, but let's break it down. To recap, the dot is like glue, sticking our player's name, player name, to the rest of the text, and this is called concatenation. The backslash is how we escape the double quotes inside our string, so PHP knows they're part of the sentence and not code. There is another way to get around double quotes in a sentence, and that's to use single quotes. As you can see in this example, the only downside with this is that if you include a variable within the single quotes, it will display the variable and not its value. It's a bit like if someone forgot your name tag and just called you name tag instead of the actual name, and we would get around this by using concatenation as per the previous example. As you can see, PHP is quite a flexible language, but my advice is to try and stick to one single method throughout, which will look cleaner and save any confusion when you come to revisit your script or troubleshoot. There's also more than one way to display text in PHP. Let's look at 3 examples. We can show HTML in 3 different ways. The first using pure PHP and curly braces, as we've seen. The second is using standard PHP tags inside the HTML. This is useful if you have a template of HTML and only want to output a couple of variables. And thirdly, something I didn't learn until later on, and that's the short echo tag, which makes your code look a lot neater, especially within HTML. All 3 display the same result. The choice depends on what's most appropriate for you. And finally, a shorthand tip for joining strings. And this is using the shorthand operator, which is a period and an equal sign. It's a quicker way to append to a string instead of writing it out in longhand like this. And this is another way we can save time and make our code cleaner. So now you've seen how strings work in PHP. For an exercise idea, you could add another variable and try adding it to one of the existing examples. Arrays. Okay, let's look at arrays and how they're used to manage collections of items in our code. If we think of a variable as a box containing a single item, then an array can be likened to a cabinet with multiple drawers, each holding an item. Each drawer can even have a label on it for easy identification. The best part is that you can reorder the drawers as well as add or remove them as needed. Let's look at a simple example. First, we create an array called inventory. Think of this array as a backpack in the game, where we can store different items. Right now, our backpack contains 2 items, a map and a flashlight. Arrays are great because they let us group related items together into a single variable, making it easier to manage them. Now let's display the items in our inventory. First, we print a heading that says inventory, then we use a HTML list to list each item in our inventory. We use a special PHP loop called Foreach, which is perfect for arrays. This loop goes through each item in our inventory array and assigns that item to the item variable. For each item, we display it in a list item li tag. So when we run the code, it will print out the items in the array as a list on the screen. Here we add a new item, rope, to our inventory. In PHP, you can add an item to an array by using the square brackets after the array name. Think of it as throwing another item in your backpack. Now we're displaying the updated inventory to see the changes. This code is similar to what we used before, but now our inventory includes rope as well. So when this runs, you'll see map, flashlight, and rope in the list. Here we're displaying a specific item referring to its position or index in the array. Arrays start counting from 0, so inventory in square bracket 0 points to the first item, which is map. Think of it like a numbered list, where the first item always has the number 0. This is an important concept in programming, and you'll see it come up often. Next, let's remove an item from our inventory. We use the unset to take out the first item by using the 0 index, which is map. It's like taking something out of your backpack and leaving a gap where that item used to be. Now we display our inventory again, and after removing the map, only flashlight and rope remain. Since we removed the item at index 0, our first item in the list is now at index 1. This is how we display the new first item, which is now flashlight. This shows how array indexes don't automatically shift when you remove an item. They stay in place, which leaves a gap in the numbering. We can illustrate the current state of our array by using var_dump, which is a way to display the contents of the array, including the indexes. Here I've highlighted one of the items in the array. This tells us that this is an array with 2 items. For each item, it will show the index, the type, in this case a string, and how many characters it is, and then the actual value. As you can see, var_dump is super useful for debugging, and it can be used on all variable types in PHP. Right now, we'll see the flashlight at index 1 and the rope at index 2, and no index 0. Here we use a function called array_values. This will reindex our array, filling in the gap left by the removed item. It's like tightening everything up so that the list starts from 0 again, and without any missing numbers. Once we reindex, we use the var_dump again to see the updated array. Now flashlight is at index 0 and rope is at index 1. This makes our array easier to work with and is neatly organised without gaps. Finally, we confirm that our first item, flashlight, is back at index 0. Let's take a quick look at sorting. We've created a new array called backpack. Right now the items are in the order that they were added, but what happens if you want to organise them alphabetically? And that's where the sort function comes in. You'll notice this time, instead of using var_dump, we're using print_r. This provides a simple snapshot of an array or variable. Once again, it tells us that it's an array and that each item will show its index number and its value. This is useful if you want to check your variable's contents without the extra detail. The sort function rearranges the items in ascending order, alphabetical for strings or smallest to largest for numbers. And after sorting, the array looks like this. Sorting isn't just about tidying up your backpack. It brings structure and logic to your data. For example, sorting a list of books by title so users can find what they want, arranging product prices from cheapest to most expensive, or preparing data for analysis or ranking players in a game. We'll be covering sort in more detail, but as you can see, it's a versatile function. Associative arrays. Okay, we're now going to explore one of the most powerful tools in PHP, and that's associative arrays. These are great for organising and accessing data in a meaningful way. We'll start simple and build up to slightly more advanced examples. Okay, so what is an associative array? Well, if we take our previous cabinet with drawers analogy, these drawers would have labels. Each label represents a key, and the items inside are the values. Associative arrays work just like that. You use keys like map or flashlight to store and access values, making your data easier to manage. Let's start with an example, a player's inventory. Here, inventory is an associated array. The keys are the item names, map and flashlight, and the values represent their quantities. So the player has one map and one flashlight. Now let's check if the player has a map in their inventory. We'll use the isNotEmpty function, which asks, does this key exist in the array and does it have a positive value? If the map key exists and is greater than 0, we print the quantity. If it doesn't, we say the player doesn't have a map. It's like asking, is there a drawer labelled map in the cabinet and is there anything in it? Let's have a look at adding and adjusting items. Let's say the player finds some rope. Here's how we'll add it to the inventory. This creates a new key, rope, with a value of 1. If we want to add more ropes, for instance adding 5, then we use the += operator, updating the quantity to 6. We can also remove ropes by using the -= operator. In this case, we take it back down to 3. You can adjust quantities like this at any time. Let's have a look at removing items. What if the player uses their map and it's gone? We can remove it using the unset function we previously looked at in the last chapter, like this. This completely removes the map key and its value from the array. If you try to reference it after this, it will no longer exist, shown here as we print the array. Now that we've explored single-layer associated arrays, let's step it up a notch and talk about nested arrays. Think of nested arrays as containers within containers. In our game world, this is how we store the data about locations. Our world array contains a numbered key to represent a location in our game, and each location has its own details like a description, possible directions, actions, and even a background image. To use this data, we navigate through the layers of the array. Let's say we want to display the description of each location. Here's how we would do it. This tells PHP to start with a world array, go to the first key, either 1 or 2, and within that, grab the description. The result is the text for each location being displayed on the screen. In this step, we're going to focus on one specific location and its details. We'll initially assign 2 to the selected world variable. Doing this allows us to dynamically change the displayed location by updating this variable. Let's start by accessing the nested array as before, but this time instead of manually using the number, we'll use the variable selected world we created to access the information we want. We've done this by echoing out the selected world we're using, in this case 2, and its description. We've also used the image path that is stored under the image key. I've prepended the path with .. as our images directory is up one level in our main project directory. In this next section, we're once again using the isNotEmpty function, which is needed for when keys might be empty or undefined. This will ensure PHP doesn't throw warnings if the directions key is missing or it has no data. So here we're looking in our world array, and our selected world in this case is 2, and we're checking if the directions are present. If directions isn't empty, we loop through the array using Foreach to list the available paths. In the same way, we also check actions with the isNotEmpty function and then use the Foreach loop to display the available player actions. Now if we go back to our selected world variable and change the value to 1, we no longer have any actions. And this is why it's a good habit to use the isNotEmpty function when working with arrays that might have optional data. As you can see, nested arrays are powerful tools for organising complex data, and as you can see, they fit perfectly into game design. If you're finding this useful, please give it a like and subscribe, as I have some great tutorials coming soon. Sorting arrays. Okay, we've covered quite a lot on arrays, and I'm sure you're beginning to see how useful they could be. One last subject on arrays we briefly touched on is sorting. Let's continue with our inventory example for our player. Currently, they're in no particular order, just stored as an associative array, where each key is the item name and the value is a quantity or string. Here's what it looks like in raw form, so this will be our reference. Let's try our first sorting method, which is sort. This one sorts the array by its values in ascending order, which is 1 to 9, then A to Z. One thing you'll notice about this method is that the keys disappear. This isn't ideal if you want to keep the original structure, and a way around this, if you just want to order the list, is to copy the array into a new variable, shown here in sorted array, and then sort the new array and work with that. This way the original array stays intact. This brings us nicely onto A sort. In the same way, this one sorts the array by its values in ascending order, but this time it keeps the keys intact. After running A sort, the inventory will be sorted by value, smallest to largest, and the keys will remain attached to their values. Next up is AR sort, which is like A sort, but in reverse. This one sorts by value in descending order, so this would present Z to A and then 9 to 1, as demonstrated here, where we see the pig value is on top. And now the largest values come first and the keys stay in place. Finally, let's sort by the keys instead of the values. For this we use K-sort. This arranges the inventory by the names like rope, map and pet and so on, while keeping their values intact. Uses for this could include creating a dictionary of terms or table of contents, where the keyword is the key and the value is the definition or page number. It could also be used in a report to order by username or categories to make it more readable. So to quickly summarise the methods we covered. Sort sorts by values in ascending order, removing the keys. A sort sorts by values in ascending order, keeping the keys intact. AR sort sorts the values by descending order, also keeping the keys intact. And K sort sorts the keys in ascending order, leaving the values attached to their key. If you're following along, try uncommenting each sort method one at a time and running the script. This way you can see exactly how each method works in your array. And now it's time to change subject. Arithmetic. Let's see how we can manage health on a player using arithmetic. Okay, let's start by setting the initial health of our player and set it to 99 points and then display it to the screen. In our first example, the player has triggered a trap and we've assigned a trap value of 20. Health minus equals trap damage is shorthand for health equals health minus trap damage. It subtracts the trap damage from the player's current health, and afterward we display the trap damage and the remaining health to the screen. In the same way, we can use plus equals to add health to our character. So here, health plus equals potion is restoring health by adding the potion value. As with a lot of syntax in PHP, there can be multiple ways of doing things. You can write it out in longhand if you wish, but this method is more efficient and will help you produce cleaner code. In a similar way, we can use multiplication to provide a power-up, doubling the health of our player. Here we've used health star equals 2, which has multiplied our player health by 2. And finally we have division. Health forward slash equals 2 divides the health by 2, which is an easy way to apply a penalty to our player. Next, we'll look at modulo. Here's where things get interesting. The modulo operator, which is a percentage sign, gives the remainder after division. Let's use it to decide if the player gets a bonus shield based on whether the health is odd or even. Our if condition checks if health is even by dividing the health by 2. If the remainder is 0, the result is true, and the shield bonus is added. If health is odd, no bonus is applied. Modulo is perfect for adding conditions in games based on value. It's a small operator, but it's incredibly versatile. One of my favourites for gameplay is to add some randomness, and there's a function for this. It's called the rand function, and it generates a random number within a specified range, which is ideal if you want unpredictable results. In this example, rand 1, 10 will give us a random number between 1 and 10, and setting the condition if random chance is less than and equals to 3 makes it a 30% chance to win the treasure chest. This approach is great when you want to simulate luck or randomness that doesn't depend on any logical state, like our shield bonus. Another useful tool is incrementing. Plus plus adds 1, while minus minus does the opposite and subtracts 1. These are perfect for gradual changes and can also be found in loops for counting each time the loop is performed. Let's finish the chapter by ensuring that the health value never exceeds the maximum limit. To do this, we first set the maximum health variable to the desired value. Then we check if the current health exceeds this maximum. If it does, we update the current health to match the maximum value. This ensures that the health never goes above 100. Sanity checks are good practice in programming to avoid unexpected behaviour and can be applied in many different circumstances. Great, you've just learned how PHP handles arithmetic. These are essential tools not just for games, but for any program that involves numbers. Have a play around with the starting health and bonuses and try and create something unexpected. Then try and fix it with a sanity check. It's all good practice. The next chapter is all about comparing values, so you may find the answer in there. Comparing values. In this chapter, we're learning about conditions in PHP. We'll keep to our theme and make decisions about whether to fight, heal, or cross a dangerous bridge based on the health of our player. We'll first start by setting our health variable to 65, and we'll just print it out to show our current health. Let's start with our first operator, greater than or equal to. Now imagine you've reached a rickety old bridge, and you need at least 50 health to cross safely. Let's write some code to check if we meet the requirement. Here, if your health is greater than or equal to 50, you can cross. Otherwise, you should wait and heal. This is how many games make decisions based on conditions. Our next operator is similar, less than or equal to. This time we'll check to see if the player's health is low enough to need a healing potion. Let's say you need a potion if your health is 30 or less. Here we're using the less than or equal to decide if a healing action is needed. Our next operator is equal to. This time we're going to make a check to see if the health is at maximum. If it is, you're ready for anything. Otherwise, you might want to look for other health boosts. As with the other logic, we first check if health is equal to max health. If it is, we echo out our message, and if it isn't, and depending on the outcome, we echo out the appropriate message. This uses double equals to check if your health equals the maximum value. The reason double equals is used instead of a single equals sign lies in the purpose of each operator. A single equals is the assignment operator, and this is used to assign a value to a variable. Using a single equals in this condition would cause the variable to be assigned a new value, which is not what we want here. Double equals is the equality operator, and it's used to check if two values are equal. There is another equality operator, which is a triple equals. This not only compares the value, but also the type, whether it's a string or an integer. It can be used, but we'll stick to double equals for this tutorial. Our next operator is the not equal to. Sometimes conditions check for things that aren't equal. For example, a merchant that only sells potions to players not at full health. Once again, we use our if condition to check if our health is not equal to our max health. The operator checks if the two values are not equal, and in our case, the merchant is checking that our player health is not at maximum. Our next operator is greater than. Here, our player is facing an enemy. Let's use the greater than operator to evaluate if they're stronger than them. We'll set our enemy's health value at 70, and then we'll use the if condition to see if their health is greater than the enemy's health. If it is, we'll print our message. In this case, we're using the greater than to make a decision about whether to fight or flee, comparing the current health to the enemy's health. Let's now look at ternary operators. A ternary operator is a shortcut for writing simple if-else conditions. Instead of writing several lines of code, it can condense the logic into a single line and uses the following structure. Let's have a look at a real example. We'll start by defining the threshold for mid-level health at 50. This will act as the line in the sand to decide which message to show. Just like the if condition, this checks if the player's current health is greater than the threshold. If true, the ternary operator moves to the value after the question mark. If false, it moves to the value after the colon. If the condition is true and the health is greater than 50, this string is assigned to message, and it means the player is in good shape to keep exploring. If the condition is false and the health is 50 or below, this string is assigned to the message and warns the player to be cautious. And finally, as it's stored in a variable, we need to echo it out to display it on the screen. Think of the ternary operator as a traffic light. The condition is the light sensor. The question mark is the green light, what happens if the condition is true, and the colon is the red light, what happens if the condition is false. It directs your traffic, your code, down the appropriate path based on the situation. So why do we use ternary operators? Well, it saves space for one, and it condenses what would have been several lines of if-else statement into a single line. And also, it keeps it readable. It's concise for simple conditions, making your code easier to skim through and understand. And with practice, ternary operators can become a handy tool for quick decision-making logic. Finally, let's use a ternary operator again, but this time we'll use it to directly echo a message. Here we're checking if a bonus can be unlocked if the player's score is greater than or equal to 100. As you can see here, ternary operators make conditions quick and easy to write and make perfect sense, particularly if your logic is short. Assessing logic. Now that we can compare values, we'll revisit our inventory, and using player health and equipment, we'll see how we can affect gameplay to create some simple game mechanics. Let me give you a quick explanation of the operators we'll be using. The first is the AND operator. This requires both conditions to be true, adding realistic constraints. And secondly, we have the OR operator, which allows multiple options for success, increasing the flexibility in our gameplay. Just a note, you might have read that you could use the words and OR instead of the logical operators. This is true, but it's important to understand that the words and OR have what's called a lower precedence compared to the operators. This means that if the words and OR are used, you may find that they're evaluated later in the expression than the operators, and for this reason it's considered best practice to use the operators to avoid any potential issues. Okay, let's set up our variables. We have an inventory array that holds the items the player has. This can be our backpack, and the items inside are the tools or equipment that the player has collected. And in this case, the player has a torch, a rope, and a map. We've assigned 70 health to our player, which we'll use to see how capable they are of handling the challenges. For the next two variables, we're using a function, and it's called the inArray function. In our first example, this checks if the player has a torch in their backpack. It returns either true if they have it, or false if they don't. Our second one is similar. The hasRope variable checks for a rope in the backpack. Now we have the tools and health to move forward. Let's move on to the first game mechanic, climbing a cliff. The player needs both a rope and enough health above 60 to climb the cliff. The if statement checks if the player has a rope, i.e. hasRope is true, and their health is above 60. If both conditions are true, as we've used the AND operator, the player can climb the cliff. If not, the game tells them that they can't. Next, we have another example, this time using the OR operator. Let's say you want to explore a cave. The rules are a bit different here. You only need one of these two items, either a torch or a rope. The if statement here checks if the player has either a torch or a rope. This is done using the OR operator. If the player has either one of these items, they can enter the cave. If they don't have either, it's too dangerous to go in. Right, with our next example, we'll make things a little bit more interesting with associative arrays, which hopefully you can remember from one of our previous chapters, but let's recap. Instead of just a list of items, we're using a more complex structure where each item in the player's inventory has a name and associated quantity. The player inventory is an associative array where the keys are the item names like map and flashlight, and the values are the quantities, 0 for no map and 1 for a flashlight. The map has a value of 0, meaning that the player doesn't have it, and the flashlight has a value of 1, meaning that the player has it. We've also assigned 80 to intelligence for our additional condition. Next, we check if the player has a map. This line checks if the map is in the inventory. If it's there and not empty, it will return true. Otherwise, it will return false. This is similar to the isSet function, but we're not just checking that it's in the array, but also that it has a value, so it's not empty, as we can't do much with 0 maps. Finally, we put together another game mechanic where the player needs both a map and a certain amount of intelligence, let's say above 70, to use the map effectively. The if statement checks if the player has a map, using the hasMap variable and their intelligence is above 70. If both conditions are true, we tell the player that they have the map and its quantity. Otherwise, we tell them that they need a map and intelligence to proceed. You need both the map and the brains to figure it out. So that's it. We've gone through how to handle the inventory system, check the right equipment, and use player health and intelligence to determine whether they can perform certain actions in the game. By using simple conditions like if and in array, it can give the game some real depth. Okay, if you have any questions or something wasn't clear, feel free to drop them in the comments below. I'm pretty quick to respond. And if you want a challenge, take the example code that we've worked on and try adding a third condition. For instance, you could check if a player has a compass or a certain amount of gold to make the logic even more interesting. Defining constants. In any adventure, there are rules and constants that don't change. For instance, setting a maximum health value for our player or an inventory limit. In PHP, we define constants using the define function. Here's how we set them up for our game. Max health represents the player health a player can have, which we've set to 100. Inventory limit is the maximum number of items a player can carry, and we've set it to 5. They're typically written in all capitals, which isn't mandatory, but is considered best practice to make them easily recognizable and avoid confusion later on. Okay, in our next example, we're going to restrict our player's health when drinking a potion. First, we define a health variable to represent the player's starting health, in this case 85. We define a potion variable to represent the health points restored, in this case 20. We add the potion value to the player's health using health plus equals potion. Then we use some logic to check if the new value exceeds max health. If it does, we reset it to the maximum value. This ensures the player's health can never go over 100. We also display a friendly message to the player to let them know their current health. Let's look at another example. This time we'll prevent the player picking up any additional items if they have reached their inventory limit. Let's break down the code. We start with an array of items in the inventory. Loot item represents a new item the player wants to pick up, in this case a spade. We use the count inventory to check how many items are in the inventory. This is a built-in PHP function. If it's equal or greater than the inventory limit, the player gets a message saying that they can't carry more. If there's space, we use inventory square brackets equals loot item to add the spade to the inventory. Finally, we display the updated inventory using implode to join the items into a neat list. Now, if we add another item to our array, the player is starting with 5 items. And in this case, the logic would return true when trying to add another item, and we get the item limit reach message. One thing we haven't used before is implode. This is another one of PHP's handy built-in functions. What it does is takes the items in your array and combines them into a single string. You'll notice it also takes a parameter. In our example, we use a comma, but you can choose anything you like, a space, a dash, or even words. It's perfect for things like inventories, shopping lists, or any time you want to turn an array into something more readable and user-friendly. Here's a few extra tips when working with constants. Group related constants together. For example, all game-related constants go at the top of your file under a comment like game rules. Use descriptive names. Good names like max_health are easy to understand. Avoid vague names like mh or just x. Constants aren't just for numbers. You can use them for fixed strings like defining the game title. These little habits will help your code look more professional and easier to debug. And there you have it, constants in action. We've seen how to define constants and use them to manage game rules like health limits and inventory size. If you're following along, try changing or adding your own constants to the game. Maybe create a constant for maximum stamina, or try adding more items to the inventory, or changing the limit. Branching alternatives. Every good adventure is full of decisions. Let's have a look at branching alternatives, specifically if, ELSEIF, and else statements. These constructs allow your script to make choices based on conditions, guiding it down the right path depending on the data it encounters. We've covered if and else statements, but I think it's worth giving them their own section so we can examine ELSEIF and nested statements in context. Let's set up our variables. We have the player's action, set to give item. This is simulating the value of a search button the player has pressed. We'll use this to see what we give for the current area. The current area, in this case we've set it to forest. The inventory array, and this is where we'll be storing our items. The game world, this is an associative array with a structure defining what actions are possible for each area. Right, we've set the stage. Let's go and make some decisions. The simplest form of decision making starts with an if statement. This checks if a condition is true, and if it is, it executes the corresponding code block. This example does 3 things. Checks if the action exists in the current area. If the action give item isn't available, the code skips everything. 2. Assigns the value from the give item action into the item variable. 3 checks if the item is not in the inventory. If the inventory is empty, which would return true, the item gets added. And 4 finally displays a message. You added a shiny gem to your inventory. Notice that we're setting the inventory item to true. We could change this to an integer and pass the value of 1 so that we could increment the quantity. But in these examples, we'll just use a boolean and settle for single items for simplicity. 1 for an item is present and 0 for an item is not. Now let's improve our logic to handle duplicate items. This is exactly as before, but this time instead of doing nothing, we use the else statement to handle the false outcome, i.e. the item is in the inventory and will display a message to let the player know. Right, let's take this further by limiting how many items the player can carry. We'll use a constant to set the maximum inventory size. Hopefully you remember the constants from our last chapter. We'll also fill up the inventory by setting each item to true. This time, our if statement checks if the condition is true and determines the number of items in the inventory array using the built-in PHP function count. If the condition is false, it moves to the second check using ELSEIF. Since the item has failed the first check, it must already be in the inventory or the inventory has reached its limit. At this point, we check if the limit is met. If this check returns true, we set the message to inform the player their inventory is full. If the check returns false, there's space in the inventory, but it must mean we already have that item, so we set the message accordingly. You can also use multiple else if statements, but it can get a bit messy. There's other potential solutions, such as the switch statement, which we'll cover in the next chapter. Finally, let's look at a slightly more complex example. Sometimes decisions depend on multiple layers of conditions, and this is called nesting, where we place one if statement inside another. Let's unset our shiny gem so we can rediscover it. This time we've refactored our conditional statement, which means we've rewritten our code in a different way, usually to be more efficient. First, we check if the array slot for that item in the inventory is not empty, i.e. the slot for the shiny gem is not set to true. If it returns true, we can simply echo that we have already got that item. If not, we move to the else statement. Here we see our first nested condition, where we check if the number of items is less than the inventory limit. If this returns false, meaning the inventory has reached the hard limit, we echo that the inventory is full. However, if it returns true, we encounter yet another nested conditional if statement, where we check if the item is a shiny gem. We then echo out the appropriate message, and regardless of the outcome, we add the item, as that step occurs just outside the nested if statement. It's a bit like navigating through a flowchart, ensuring all the rules are followed. I think this chapter was challenging enough, but as always, if you have the time, try adding other additional conditions and playing around with the values to see how they affect the outcome. Switch statements. Okay, let's look at another decision-making concept with PHP's switch statement. This approach is perfect for scenarios with several distinct options, such as selecting items from a menu, responding to user action, or implementing game mechanics. Let's start with the basics. The basic structure is as follows. First, we start with a switch statement and our test value. We open our brackets, and inside we have each of our cases. Each case has a match value, a colon, and the statements to execute when matched, followed by a break clause. And finally, at the end, we have a default statement with the statements to execute when no match is found. The default is optional, but it's always useful to have a fallback, a bit like an else statement, as shown in the previous chapter. One thing to also bear in mind is that no case statements should match the same value. Let's look at a basic example where we match on a string. Here we use a player's selected action, in this case attack. We then build the switch statement to take our action test value. We then place each case, match value and statement to execute, followed by the break clause, one after another. For efficiency, it makes sense to place the most common choice at the top, but unless you're processing thousands of these per second, it's really a negligible gain. Finally, we end with our fallback. So when the script is run, the value action is compared to each case. When a match is found, the associated block of code runs. If we didn't have the break clause, the code would fall through to the next case, running all subsequent cases until the end of the switch. Finally, default acts as a safety net, handling unexpected inputs. When you have a predefined list of choices, you can see how a switch can be cleaner and more readable than multiple if-else statements. Okay, switching isn't just for strings, so here's a case that involves numbers, for instance, selecting options from a menu. Once again, the structure is the same. Here, the switch evaluates numeric inputs to match the player's choice. This can simulate game inputs or inventory systems. Switch also works great with numeric ranges, so you could even put an expression in like this. We'll have a look at these in the next example. Right, let's simulate a player opening a loot box. This time we've created two variables. The first is the outcome from a random function, and the second is the player's level. First, we'll echo the outcome. And this time we start our switch statement. Instead of putting a value to evaluate, we use the boolean true. So the first case statement we evaluate that is true will execute. Here's an explanation of each of the case statements in our switch block. The first case triggers if the outcome is 30 or less, and the player's level is below 10. This is tailored for low-level players, and they'll find a small health potion and recover 10 health points. The second triggers if the outcome is 30 or less, regardless of player level, and is a perfect fallback reward for higher level players. The third triggers if the outcome is between 31 and 60 and is an even number. On this specific outcome, a mysterious artifact is discovered and the player's intelligence stat increases by 3. The fourth triggers an outcome if it's between 61 and 80 and the player's level is 5 or higher. This is a reward for mid-tier or experienced players, and they find an enchanted shield boosting their defense skill by 5. With the fifth case, it triggers if the outcome is greater than 80, which is a high tier reward where the player receives a legendary weapon, increasing their strength by 10. And finally, our default. This triggers if none of the above cases match, and the player finds nothing of value, just dust. You can also nest switch statements for layered decision making, but use this sparingly to avoid confusion. You can probably imagine how you could quite easily utilize this for user roles in a web application. For example, an admin can manage content, a moderator reviews comments, and a user can only view posts, and add a fallback for guest users. Match statements. In the previous chapter, we looked at switch statements. Switch statements are available for all versions of PHP, but there is a more concise method, and that's PHP's match expression. It's very similar to switch, but I think once you see it, you might switch to match. Let's look at a basic example where we match on a string. Here we use the player's selected action. I've randomly generated it for this example, but typically this will be a player interaction, such as clicking a button or entering text. In the example, we prepend the match expression with echo. This means it will display whatever has been set as the return value. The value of action is compared to each match value. When a match is found, the associated block of code runs after the equals greater than, which is also known as a fat arrow. If none of the cases match, the default case runs, handling unexpected inputs like an invalid action, e.g. look confused or dance. Match is particularly useful when comparing a limited set of values, and its syntax is more concise than switch. This makes it an excellent alternative for simple matching tasks in games or other applications. Match isn't just for strings, and here's an example involving numbers, such as selecting an item from a menu. Here, the match expression evaluates numeric inputs to match the player's choice. This could simulate game menus, inventory systems, or other decision-driven mechanisms. Let's look at our third example, and we'll simulate a player opening a loot box. We'll use a few variables, one for the outcome of the random function, one for the player's level, and two more representing strength and health. We'll use match with multiple conditions to tailor the outcome. We will also store the output as a variable to make it more flexible. The key point here is that we're now using true. This is so that we can write complex expressions within each case, like comparing values or using logical operators. Let's look at each of the match statements. The first triggers if outcome is 30 or less, given a 30% chance, and the player's level is below 10. This is tailored for low-level players. They find a small health potion and recover 10 health points. I've also added 10 health to their base health. The second triggers an outcome if it's 30 or less, regardless of player level. So if the first case didn't match, e.g. because the player level is 10 or higher, they find a basic healing herb that adds 5 health points. It's a fallback reward for high level players. Once again, the extra health is added to the base health and printed with the result. The third triggers if the outcome is between 31 and 60 and is an even number. We use modulus 2 equals 0 to check for evenness. On this specific outcome, a mysterious artifact is discovered and the player's intelligence stats increase by 3. Number 4 triggers if the outcome is between 61 and 80, given a 20% chance, and the player's level is 5 or higher. This reward is for mid-tier or experienced players, and they find an enchanted shield boosting their defense skill by 5. The last condition triggers if the outcome is greater than 80, giving a 20% chance. This is a high-level reward where the player receives a legendary weapon, increasing their strength by 10. I've placed the strength plus equals 10 inside within the string, so this both displays the result and raises the base strength by 10. And finally, we have default, and this triggers if none of the above cases match. Key things to remember is that match uses strict equality, so that values like 5 as a string won't match 5 as an integer, and this ensures comparisons are more predictable and accurate. As with Switch, you can use this for user roles in a web application. For example, an admin can manage content, a moderator can review comments, a user can only view posts, and the default could be for guest users. Our next chapter is loops. For loops. Let's start with a recap of Foreach for arrays, and then move on to the flexible and powerful for loop. By the end of this chapter, you'll be equipped to handle repetitive tasks with ease. Here's a quick reminder of how a Foreach loop works by revisiting our inventory array. In this example, inventory is an array containing the player's items. The Foreach loop iterates through each item in the array, assigning it to the variable item. Inside the loop, the current item is displayed using echo. This makes Foreach a simple and effective way to process every element in an array. Whereas a Foreach loop iterates over elements in an array or collection, a for loop gives you control over the iteration process, typically using a counter. The for loop starts with 3 parts inside its parenthesis. This initializes the loop counter quest to 1. This is the condition that must remain true for the loop to continue. In this case, the loop will run while quest is less than or equal to 5. And the last part increments quest by 1 after each iteration, ensuring that the loop progresses. Inside the loop, the ran function generates a random number between 10 and 50, simulating the gold earned on a quest, and this value is stored in gold earned. The plus equals operator adds this value to total gold, keeping a running total of all gold earned so far. Finally, a message is displayed for the current quest showing how much gold was earned. Once the loop ends, when quest exceeds 5, the total gold is displayed using echo. This demonstrates how a for loop can repeat a task for a set number of times while accumulating or processing data. Let's have a look at a more advanced loop where a player and enemy battle it out. We introduce a player health variable set to 100 at the start. This represents the player's life force. The enemy attack value, randomly generated between 5 and 15, determines how much damage an enemy can deal to the player during combat. Inside the loop, each enemy's attack is considered. If the enemy's health is 30 or less, the player defeats them easily and no damage is taken. Otherwise, the enemy fights back and the player takes damage equal to the enemy attack. This damage is subtracted from the player's health using the minus equals operator. After each battle, the player's health is checked. If player health drops to 0 or below, the game ends and a message is displayed. The break statement exits out the loop to stop further processing. If the player defeats all enemies without their health dropping to 0, a victory message is displayed, showing the remaining health. By directly inserting variables into each message, we ensure that each one reflects the unique stats and outcome of the encounter, creating a more engaging and interactive experience. This example has shown how we can introduce the break statement to exit under specific conditions. For loops are perfect for scenarios where you know in advance how many iterations are needed, such as processing a fixed number of quests or enemies. They give you control over the starting point, end condition, and increment, making them incredibly versatile. Up next, we'll explore another type of loop, the while loop, which is better suited for situations where the number of repetitions isn't known beforehand. While loops. PHP while loops are like a spinning wheel, running the code until the condition signals it's time to stop. They're used frequently, especially when working with tasks involving repetitive actions or processing data. One common application is with database queries, which we'll cover in a later chapter. Let's walk through an example. The code begins with the initialization of 2 variables. Collected items is set to 0, representing the count of items collected so far, and the required items is assigned to the value of 5, which is the total number of items needed to complete the task. These variables establish a starting point and the goal for the loop. Next, the while loop evaluates its condition. Are collected items less than required items? As long as this condition is true, the code inside the loop will execute. The condition ensures that the loop continues running until the number of collected items matches or exceeds the required amount. If the condition is false at the start or becomes false during the execution, the loop terminates. Within the loop, the code executes repeatedly. On each iteration, a message is printed to indicate which item number has been found, calculated as collected items plus 1. After displaying the message, the value of the collected items is incremented by 1 to reflect the progress made in collecting items. This ensures the loop progresses towards its termination condition. The loop ends when the collected items equals 5, causing the condition collected items less than required items to evaluate as false. At this point, the loop stops executing and a final message confirms that all items have been gathered, signifying the task's completion. Simple counters are one use case, counting iterations, tracking progress, or managing repetitive tasks. Game mechanics is another, collecting items or managing player actions. One of the most powerful applications is with database queries, where it can fetch and process multiple rows of data. This next code runs an infinite loop whilst true, meaning it will keep running until explicitly stopped using a break statement. The variable steps, starting at 0, increments by 1 on each iteration, tracking how many steps have been taken. A condition inside the loop checks if steps is equal to 5, and when the condition is true, the break statement halts the loop. Until then, the loop prints the current step number on each pass. This approach ensures the loop runs indefinitely, but stops once the player reaches 5 steps. Event loops are a use case for this one, continuously listening for events or input, i.e. user interactions, or game loops, running a game logic until a specific condition is met, and processing data, waiting for a process to complete dynamically. In our third example, we'll look at breaking from loops. This code begins with the initialization of two variables. Attempts, set to 0, keeps track of how many searches have been made, while hasFoundKey, initially false, indicates that the key has not been found yet. These variables set the stage for a search operation. The loop's condition ensures that it will keep running as long as attempts is less than 10. This places an upper limit of 10 attempts on the search, preventing the loop from running indefinitely. Within the loop, a random chance determines whether the key is found. The random function generates the random number between 1 and 5. If the result is 1, representing 20% probability, it means the key has been found. When the key is located, the loop is terminated using the break statement, and hasKeyFound is set to true. This ensures the program stops searching once the key has been discovered. Finally, a post-loop check determines what happens next. If hasFoundKey is true, a message confirms that the key was found and the task can proceed. Otherwise, a different message indicates that the maximum attempts was reached without success. Some use cases for this would be randomized scenarios, retry logic, repeating actions until success, such as retrying a failed API request, and database queries again, iterating through a result set to find specific data. Okay, we're done with loops now. If you do have the time, I strongly suggest trying a few examples and playing around with the code to reinforce those concepts. Functions. Now we're going to have a look at something that's a real time saver, and that's functions. Functions are reusable blocks of code that perform a specific task. They allow you to organize your code, reduce repetition, and make your programs easier to read and maintain. Let's have a look at their structure, uses, and best practices. A PHP function consists of these parts. 1. A declaration using the function keyword. 2. A name, a unique name to identify the function. 3. Parameters, which are optional. These are input values the function accepts. And a code block. This is the set of instructions that the function executes. And finally, an optional return value, a value the function sends back to where it was called. Let's start by exploring a simple function that doesn't take any arguments. This function uses an array to store a list of possible treasures and a built-in PHP function called ArrayRandom to randomly pick one. If you remember from chapter 3, an array is a collection of items, and in this case it holds strings describing different treasures. The ArrayRand function selects a random key or index from the array, which we use to retrieve the corresponding treasure. The function also returns a value, which means it sends back a result that we can use elsewhere in our program. You can see how this works when we call the function and display the treasure message. When we call find treasure, it executes the logic and sends back the message. We store that message in the treasure message variable, which we then display with echo. This approach allows us to reuse the treasure discovery logic without repeating code. Now let's have a look at a function that uses parameters. Parameters act like placeholders for values that you provide when calling the function. This makes the function more versatile, allowing it to handle different situations based on the input you give it. In this example, we use the apply bonus function to calculate a bonus. The function takes a base value, like damage or gold, and a percentage to determine the bonus amount. Notice that one of the parameters has a default value, bonus percentage equals 10, which means if you don't provide a value for that parameter, it'll automatically use 10%. This function also uses return, just like the previous example, to send back the calculated result. When we call the function, we pass specific values for the base amount and the bonus percentage. The function performs the calculation and returns the result, which we can store in a variable and use in different contexts. Functions like this are incredibly useful because they allow you to handle calculations consistently throughout your program without rewriting your logic. Some key points to remember. Function names. These must start with a letter or underscore, followed by letters, numbers, and underscores. Avoid using names that clash with built-in PHP functions. And when and why do we use functions? Well, the advantages of functions are reusability, write once, use multiple times, organization, break down complex tasks into smaller, manageable pieces, maintainability, changes in the function affect all its calls, simplifying updates, and readability. Properly named functions will make your code self-explanatory. Another thing to mention is understanding variable scope. Variables in PHP have boundaries called scope. Variables created outside functions are global, whereas variables inside a function are called local, accessible only to that function. Functions can't see global variables unless you explicitly allow it. This is to prevent confusion and accidental overwrites. Let's take a look at these examples. As we see in the first example, gold coins is not accessible here. If you look in the second, we use the global keyword to grant access to the global variable. A better approach though is to pass variables. Instead of relying on global, pass the variable directly, as in this example. I think the key takeaway here is to use global sparingly. Passing variables keeps your code organized and avoids potential errors. IsCallable is quite an advanced technique, but we'll be using it in our project to check if an action is available and has a function that is usable, so I'll explain it a little here. IsCallable is used to determine if a function can be called. It's helpful in a dynamic or modular code where function names may vary. You can see it used in this example, where we're using it to see if hello is available. If it is, it outputs hello world, and if not, it will echo the function hello is not callable. This flexibility makes IsCallable value for advanced projects. I'll explain more detail when we look at it in our project file. Let's move on to superglobals. Get requests. So get is a method of sending data to the server via the URL query string. Query strings appear after a question mark in the URL with key value pairs like choice equals forest. PHP retrieves these values using the get superglobal, which is an associative array containing all the get data. Let's walk through the example. Get choice looks for a value associated with the key choice in the URL. Double question mark start. If no value is provided, e.g. choice equals nothing or no query string at all, it defaults to start. This line ensures that the game has a default state even if no choice is specified. Here the code checks the value of choice and displays the corresponding message. This simple decision making creates dynamic content tailored from the user's input, and at the bottom we've got a list of links with a different value for the choice in the URL. By clicking any of the links, it reloads the page and changes the output based on the new value of choice. So what can get do? Well, get is perfect for scenarios where data needs to be shared via links, like search queries or user choices in games. And since get data is included in the URL, the page can be bookmarked or shared, retaining the current state. And finally, it makes it easy to test different inputs by modifying the URL directly. What get is not ideal for is sensitive data, because get exposes information in the URL, so it's not secure for passwords or private data. And also the same for large data. Browsers and servers limit the length of URLs, making get unsuitable for large data sets. Post requests. Okay, now we'll introduce you to the post variable, a more secure and versatile way to send data from the client to the server. Post enables interactions like submitting forms, sending login data, and processing game choices without exposing data in the URL. Let's build on our last examples. This first line checks the request method used to access the page. Post requests are initiated when a form is sent with the method equals post. By ensuring we only process data when the request is post, we avoid accidental errors or warnings when the page is first loaded. This retrieves the value associated with a key choice in the submitted post data. And we can see here it defaults to start if no value is set for choice. This ensures our game has a fallback when no choice is submitted. Once again, depending on the player's input, a unique message is displayed. The if statements evaluate the value of choice and output the appropriate response. In creating the form, we ensure we use the method post. This specifies that the form data should be sent using the post method. Action with no value sends the data back to the same page. You can replace this with another URL if needed. And each of the buttons has a name of choice and a unique value, forest, castle or start. And when clicked, the button sends its value to the server as post data. In summary, the post variable is powerful and versatile, making it ideal for handling form submissions, modifying database records and sending large data. However, it must be paired with HTTPS to securely handle sensitive information like passwords. Additionally, you must always validate and sanitize data received by post to prevent vulnerabilities like SQL injection or cross-site scripting. Sessions. Okay, let's have a look at the final part of our superglobals section. Session variables allow you to persist user data, like game progress, login status, or choices, without exposing it to the URL or relying on form submissions. Before we look at the example, let's have a quick look at how session variables work. The session start function must be called at the top of every page where session variables are accessed. Each user is assigned a unique session ID stored in a cookie, or passed via URL for non-cookie users. The session variables are stored on the server and tied to the session ID. Okay, let's have a walk through the code. This initializes or resumes the session, and it ensures the server can access or create session data for the user. This verifies the request method is POST to process form data. This line checks if a specific form field called control has been submitted. The isSet function checks if the variable exists and is not null. If the control field is found in the form data, this means our quit button has been pressed and the code inside this if block will run. If the control field is set, this line will end the current session by calling session destroy, and this means our session variables stored on the server will be deleted and the session is closed. After destroying the session, this line sends a location header to the browser, telling it to redirect to a different page, in this case, back to page 1. This will cause the browser to load the page instead of staying on the current one. The exit function is used to stop the script and running any further. This ensures that no additional code is executed after the redirect, preventing any unexpected behavior. If the control field was not set, the code moves to the else block, which will run if the form was submitted without the control field. This line then checks if a choice field was submitted in the form, and if it was, it stores the value in a session variable called choice. If the choice field is not set using the double question mark operator, it assigns no choice made as the default value. And lastly, this line prints the message to the browser, letting the user know that their choice has been saved. We're finally presented with 4 buttons: go to the forest, visit the castle, stay at the crossroads, and clear my session. The form submits data to the same page using the post method. Clicking one of the 3 buttons sends post data with the name choice and a corresponding value, e.g. choice equals forest. Using the logic above, the PHP script saves this value in a session using session choice, and the user sees the confirmation message. If the user clicks clear my session, the form sends the post data with control equals quit, and once again the logic handles this by clearing the session data using session destroy and redirects the user back to the same page. Additionally, the user can click visit sessions page 2, which takes them to another page we'll look at in a moment, and this page retrieves and displays the saved choice. If the session was cleared, it displays the default message indicating no choice was saved. This process allows choices to persist across pages or be reset entirely. And this line outputs the entire session array for debugging or learning purposes. Let's look at page 2, which resumes the session. This here ensures the choice exists in the session before displaying it, and uses HTML special characters as a security feature to display the output and prevent HTML injection. And this line allows the user to return to page 1 to make a new choice. Let's take a look at the demo in action. First, we click Go to the Forest button. This saves the value forest under the choice key in the session array. If we navigate to the second page, we can see that the session data persists, showing forest as the stored choice. Next, if we return to the first page and select Visit the Castle, this updates the session with the new value Castle under the choice key. Heading back to the second page confirms that the updated value still persists in the session. Finally, we return to the first page and click Clear My Session. This action clears the session data completely. When we visit the second page again, the session is empty, confirming that the session was cleared. This demonstrates how session data can be saved, updated, and removed across pages. So let's go through the advantages of session variables. 1. Data persistence. Session variables persist until the session ends, e.g. the browser is closed, or a session is explicitly destroyed. Security. Data is stored server-side, reducing the risk of tampering compared to get or post data. 3. Ease of use. There's no need to pass data manually between pages. The session is accessible anywhere with session start. Common use cases are for login systems, storing authentication status, shopping carts for keeping track of items across pages, and games, saving progress or player choices. Let's make the game. Welcome to the final section of PHP Quest. Throughout the previous tutorials, we've used game development as a vehicle to explore these fundamental web development principles. You'll now see how it all fits together and how PHP can create a dynamic interactive web application that could respond to user input and maintain state across multiple page loads. In this project, we're going to cover session start to track players' progress across different pages. We're going to organize the game data using PHP arrays. We're going to handle post requests to process the player's actions. and we're going to be dynamically generating HTML based on the game state. We're also going to be implementing a basic inventory management using PHP sessions. In part 2 to PHP Quest, we're going to take our web development skills further by integrating MySQL for data storage and implementing a CRUD, which is create, read, update and delete system to handle the game data. Let's walk through building the project. This is the first line of the PHP script. The session start function is essential. It allows you to track user-specific data across different pages. In this game, it will store the player's progress, such as their location or the current area, and inventory. When you start a session, PHP creates a unique identifier for each user, often stored in a cookie, and it allows you to store values that persist as long as the session is active. And this is why we can remember the player's location and inventory across different pages. Here, the includeWorldArray.php statement brings in another PHP file that contains an array representing the game world. This array holds the locations of the game and what directions are available at each location, possible actions, and even items that the player might find. This file will essentially define the world. Without it, the script wouldn't know where the player is or what actions are available to them. Let's take a moment to have a look at the array and some of the entries. We'll start with location number 1, which has a description of a sunny clearing surrounded by tall grass with a dense forest visible to the east. This will be displayed to the user if this is the current area. Players can move north to area 9 or south to area 2, and these will be displayed as buttons on the display. There aren't any actions available here, so no action buttons will be shown. The scene is brought to life with a background image, and this has the cover attribute applied to it in the CSS file, which is used to ensure the whole background is covered, maintaining its aspect ratio. Area 6. As with all of the locations, this has a description which will be displayed on the page along with the directions, allowing the player to head north to area 5 or east to area 4. This time we have an entry in actions with the key of search, which if this is the current area will be displayed as an option to press in the form of a button. If the search button is pressed, the logic will check if the corresponding give item key is set and has a matching key search, and will therefore return the value key, which is the item that will be placed in the player's inventory. We'll discuss the logic next. And finally, we have the background image used to give the game some visuals. Area 7. As with all the array elements, we have a description, directions, and an image for the background. However, this time we have something different. Under the actions key, we have another key called enter, which as with all actions will be displayed as a button. Instead of a static response, the value for this action is a function. This is a dynamic piece of logic that checks the player's inventory for a key stored in the session. And here's how it works. If the player has the key is set session inventory key, evaluates as true. The function returns you unlock the door and step into a library filled with ancient books. If the player doesn't have the key, the function instead returns the door is locked and you need a key to enter. This makes the enter action context sensitive, providing a different result depending on the player's state. These are the main concepts you'll find in the array. The values will change, but the logic behind them remains the same. Talking of logic, let's have a look at that now. In this block of code, we're checking whether the player has a saved location or inventory in the session. This checks if the current area variable is set in the session. If not, it means the player is visiting the game for the first time or the session has expired. If the player doesn't have a location saved, they're placed in the starting area, in this case area 1. Similarly, the player starts with an empty inventory, represented by an empty array. This inventory will store the items the player finds during the game. In this part, we check if the user has submitted a form. When the form is submitted, PHP checks server request method. This tells us if the request method was a post request, meaning the player has clicked a button or submitted something. This grabs the player's control input, usually a reset command or similar. The double question mark null is a shorthand way of checking if the control key exists in the form data. If it doesn't, it defaults to null. In the same way, this retrieves the direction the player wants to move, like north, south, etc. This line retrieves the action of the player wants to perform, such as search or look. And this stores the current area the player is in from the session in a more concise variable, so we can look up the directions and actions for that location. This is the part where we check if the player wants to reset the game. If the player sends a control input, e.g. clicking the quit button, the following happens. Session destroy, this clears all the session data, effectively resetting the player's progress, such as their location and inventory. Header location indexed PHP, after destroying the session, this redirects the player back to the main game page, index.php. This is where the game starts. And finally, this line ensures that the script stops executing after the redirection. Here we're checking if the player is trying to move to a new area, and movement is handled by the direction variable. This checks if the player has specified a direction and whether that direction exists in the current area. The world array holds all possible directions for each area, and if the direction the player wants to go is valid, we proceed. If the direction is valid, we update the player's location to the new area using the direction from the directions array. Here we store a message confirming the move, which can be displayed to the player. And here, if the direction is specified but not valid, we set the message to let the player know that they can't go that way. This checks if the player has provided an action and if that action exists in the current area's actions array, e.g. search or explore. Each location may have a set of actions that the player can perform. Here we store the result of the action. This could be a string like a description, or a callable function like a function that triggers an event. And here we check if the result is callable, i.e. a function. If it is, we call that function. Otherwise, we just display the result as a string. After performing an action, we check if the action grants the player an item. This line checks if there's an item to give based on that action. If the action results in an item being given, we retrieve that item. Here we get the name of the item being given to the player. This line checks if the player already has the item in the inventory, and if the player doesn't already have the item, we add it to their inventory using the session. And finally, we append our message to tell the user that we've found the item. If the player has provided an action but it doesn't have any effect, i.e. it doesn't exist in the actions array, this else statement will be executed and the message, nothing happens, is displayed to the player. The next section of code provides the front-end interface for our game. It integrates PHP logic with HTML to display the game state, handle user input, and present dynamic content like directions, actions, and the inventory. Here's a breakdown of the key PHP elements. This line sets the background image of the web page dynamically using the current image variable, which was assigned earlier in the PHP script based on the current area in the world array. This ensures the background matches the player's location in the game. We'll include a div element that acts as our container for our messages and buttons. This is where the player will interact with the page. The layout and the design of the page will be styled using an external style sheet, which if you'd like more detail, we'll cover as a bonus section at the end of the tutorial. Next, we'll add an image displaying our PHP Quest logo. This image is styled in line with a width set to 400 pixels to ensure it fits well within the container. This is the message variable that we've been building throughout the logic. It stores the result of the player's actions, such as movement or interacting with objects. This content is generated by the PHP script in response to the player input, providing feedback on what happens next in the game. This line dynamically pulls and displays the description of the current area based on the player's position, and it retrieves the description of the world array, which as we've seen holds the details for each area, including text descriptions of the environment. Here the player's inventory is shown. If the inventory is empty, it displays nothing. Otherwise, it lists all the items in the array using the array keys to get the item names. You can learn more about implode in chapter 9 of this series. In short, it takes the elements of the array, in this case the key names, and puts them together in the form of a string with comma separation. This is dynamically updated based on the items the player has acquired during the game. This block generates a series of buttons for the available directions. It loops through the directions array of the current area and creates a button for each direction. This type of for each loop is commonly referred as a short circuit or inline loop, as it's compact and combines logic with HTML output in a single line or block. Here's a breakdown. This is a regular for each loop, where the world session current area directions is an array of directions. Each direction, such as north, south, etc., is assigned to a direction, and area represents the corresponding area the direction leads to. Inside the loop, HTML is being outputted dynamically for each direction. This line creates a button for each direction and the direction name like north, south, and it uses the built-in PHP function UCFirst, which capitalizes the first letter for better readability. Similar to the direction buttons, this block generates a set of action buttons based on the available actions in the current area. It loops through the actions array for the current area and creates a button for each action. The button will submit the action and the corresponding response, action outcome, will be shown as a result. This form contains a single button for quitting the game. It allows the player to send a post request with the control parameter set to quit, which triggers the game reset functionality defined in the PHP we discussed in the logic section. It destroys the session and redirects to the home page. Finally, the block that's commented out provides a convenient place for debugging. The var dump would print the entire session data to help check the player's current state, and the other print statement could just show the current image for the area, which might be useful for debugging the image path. This whole code ties the front-end HTML with PHP logic, making the game interactive and responsive to the player's decisions. If you made it this far, congratulations, and I really hope you've learned something, and I'd love to know in the comments what your first project's going to be, or if you've made any mods to this game. My next video in the series, PHP Quest Part 2, will focus on MySQL database integration, allowing us to store our game data more effectively, and we'll create an interface to manage it, edit it, and add new areas. Without further ado, here's CSS. Alright, so we've got two main sections here, the body which covers the entire page, and the container which is the box in the middle. If we look at the styles, the body has properties that affect the whole page, including the container. First up is the flex property. This helps with centering elements. Justify content centers the elements left and right, while align items centers them top and bottom. If I remove them, you'll see the difference. They snap back into their default positions. Adding them back ensures everything is aligned neatly in the center. We've also given the body a height of 100 VF, which ensures that it takes up the full screen, even if the container is smaller. The margin is set to 0 to reset any default spacing. Then there's the background. Background size is set to cover, so this image fills the page without repeating. And the background position is centered to keep the image focused. The font settings make the text easier to read with a custom font family and a slightly larger font size. Now onto the container. It has some padding around the edges to give it some breathing room. The background colour gives it some contrast, as you can see that if we remove it. The text colour is set so the text is readable. Again, without it, it blends in. The border radius property gives it the rounded corners. There's also box shadow. It's a subtle effect that gives it just a bit of depth, as you can see, just around the edges. The container's width keeps it tidy, and its height is set to auto, which means it adjusts based on the content inside. The text is aligned in the center with text align center, so if I comment that out, everything shifts to the left, and as you can see, this also affects the buttons. Speaking of which, let's have a look at their styling. The padding adds some space around the text inside. If I remove it, they shrink and don't look particularly great. The background color keeps it within the theme, and the text color ensures that it stands out. I think white looks a bit cleaner here. By default, the buttons have a border, but we've removed that because I think it looks better. The border radius rounds the edges again, and this property affects the cursor when you hover over the button. The margin property ensures the buttons don't stick too close together, giving them some spacing. And finally, there's a smooth transition effect that you get when hovering over it, and without it you can see that the hover effect is abrupt, again making it a bit more visually pleasing. And last but not least, the hover background colour adds a subtle darker shade when you hover over the button. And that's the CSS. There's quite a lot going on, but it's fairly straightforward once you break it down. Thanks all!